Well, the Ryobi sprayer has gone bad. I've used it probably 2 times. I bought it February of last year, and I gotta say honestly, when it works, it is really nice. You throw an 18-volt battery in it, you fill it up, mix your stuff, and you go. And especially if you're spraying with turf, it's great to have a battery-powered sprayer. If you're just doing a little spot spraying here and there, like just hitting a few weeds with Roundup or something, go with a $10 pump tank rather than manual tank. But if you're doing turf grass, like putting down tenacity and things like that, this helps a lot. Sadly, it stopped working after just a couple of uses. It's been sitting in the shed for a couple of months for sure. I absolutely cleaned it out very, very thoroughly after use, because as you can see, I used marker dye in the last one, and marker dye makes a horrible mess of everything. So this got very, very thorough rinsing afterwards, but now it won't spray. When I turn it on, I can hear the whining of the motor, but nothing comes out. It's nothing in the tube. It's not the little filter on the inside. That guy pops right out. It's very easily replaceable. It's a metal screen. Absolutely wasn't clogged in the least. I don't know if there's an internal clog, but I will say that this has gotten very little use, liquid chemicals only. So I doubt it's a clog. I suspect something else is going on. So we're going to take it apart and figure out what's happening. First thing to figure out is actually what kind of screw it takes. It's hard to get a light down there because the screws are sitting way down at the bottom. And at first I thought it was hex because it really didn't look like Torx, but I couldn't get any of my many hex keys to fit. And now it seems like it takes a T20. These are definitely M4s, but they're plastic threads, not machine threads, so I can't tell you the thread pitch. Hopefully that helps in replacing. They are Torx headed. Alright, now that we have a little bit cleared out some of those tools, made a little bit more room, let's see this guy come apart. Hopefully this might be a challenge here. We have a seam. Yeah, what am I doing? I'm obviously pulling in the wrong direction. We still have this hose blocking us there, so this apparently is intended to come apart from the front side. So let me be smart and remove that. Well, this case is already starting to go bad. That'll teach me. Alright. 2 more screws on the inside here. Let's go ahead and get those out real quick. Also Torx, going to assume they're also a T20, and they are also a T20. Apparently some daddy longlegs have been making a home in here, so that's a little bit creepy. But you know what? If you're using a garden sprayer anyhow, you're probably not too creeped out by insects. Alright, let's examine these bolts a little bit. These are the ones that came out of the battery tray. There are actually 2 brass bushings in there, so these are actually machine screws, not plastic screws. Always better done in my opinion. Plastic screws obviously are going to fail at some point. Brass bushings cost pennies, even as a consumer buying them in small amounts, so it makes really no sense in my opinion for someone to make something out of plastic and use plastic coarse threads to drive into the plastic. That's a cheap out. Since these are machine, I can actually measure them. They're definitely M407. That's feeding quite nicely. They are a pan head and Torx 20. And let's show you how long they are. I'm measuring to the outside of the head, which is incorrect. I should be measuring from the bottom up to the bottom side of the head. But still, you can look at this and you can measure from you can read the scale and add and subtract millimeters and the sort. I'm trying to make this helpful for everyone and for myself, to keep a journey of this for myself and for my own records going back when I need to fix this again. But at the same time, I am actually trying to fix this thing and get some work done. Okay, so at this point, I've removed the 7 Torx 20 screws from the back side and 2 Torx 20 4mm machine screws from inside the battery compartment. It looks like, because the hose is going through the back piece of plastic, it looks like I need to remove it from this way. I'm hoping that it's just a nice clean lift. So far, it feels like a nice clean lift.
And that fancy rotary switch in there. Other than that, this is 12-volt electronics. Pretty basic stuff. If you're new to working on things, if you're young, if you live in an apartment or were raised in a city or something, this might all be foreign to you, but surely it's not complicated.
Alright, so it looks like actually the back comes off, which is good. I can work with that. I'm going to have to reposition my station here a little bit, tidy things up. So here we have the exit hose that goes to the wand. It's a very basic hose clamp and a couple of smaller Torx screws. They are... Alright, so here we have the exit pump. It's being held in place with a single hose bracket and again a couple of smaller Torx screws. Hopefully those are coming into focus there. We have the housing pump, again held in with lots of small Torx screws. It's nice. I like seeing the Torx. Thank God they didn't go with like stupid Phillips fasteners or worse, straight edge. Would love to see the world standardized on Robinson. I'd prefer that one, but very rare usage here in the US. Okay, here we have the hose from the actual tank. Pretty hard 90 there, but structural, right? It's not a loose piece of hosing that's going to crimp. It's good quality hosing. I like this. Solidly fastened onto there. So, battery terminals. Straight down to... Yep, so okay, so it's just the rotary switch. Nothing too fancy there. And then wiring to the pump. Again, about as basic as can be. Now when I turn this thing on, I hear something whining. It just makes me think the pump is trying to move. So the first thing I want to do is, I'm going to disconnect the hose here and just make sure that there's no problem in the downstream, in the external system, and see if that'll make it shoot some water out. If it does, right, then I know I need to clear this out somehow. Now let's take a look at the quality of the hose here. Type A, let me focus that for you. Type AOF, ISO 1401. What was that saying? 8mm, 1 MPa. And then behind that is 2Q, Q is in Quebec, 2Q2021. That's the hose. And of course it fastens to the other side with a pretty basic screw-on coupler there. Nothing fancy. But here we do have a good crimped connection. And we'll figure out what the rest of this looks like here in a second. So even this guy didn't fit great. This guy fit better than the Harbor Freight one. That still didn't fit great. This is a security screw that has a pin in the bottom to keep regular Torx bits from fitting. No wonder I had to go through so many and try to find the one that fit best. This is a real jerk move, right? And in real life we use different words for that. So now I have to go find the security bits to get this thing out. And I was also wrong about the motor housing. Those also are not Torx. They're also using a security driver. I'll have to get you the lowdown on that in a second. Alright, but continuing on, there we have that T10, and that's what we need, the T10 with a hole in the middle, what they're calling T10H. So let's take a look at that guy. It does indeed have the finest of holes in the middle. Will it work? Let's see if this does the job. And indeed, it's firmly seating, and good traction to get this out now. Perfect. So my mistake, I removed one screw before I noticed it was a security screw, right? And so that gave me bad purchase on it. So I take back everything bad I said about Harbor Freight, and how doing individual bits is better. I'm going to have to reassess that. That was my mistake. I fess up to it. Now we have that hose clamp off. Let's measure these guys for you real quick. They are a very coarse thread. Length. Diameter. I realize that's near impossible to tell. It is Torx 10 with a hole. Alright, sorry I couldn't get this guy to fit my thread checkers, and I have a thread pitch gauge that probably has some more variety to it, but I'm not sure where it is right now. It seems to be about a 3mm. It just seems to be some random coarse threading for going into the plastic. There's definitely no bushing in there. It's just plastic, and as a reminder, all it's doing is holding the hose clamp in place, right? So not super structural. If you needed to replace the screws and you couldn't get the threads to line up, you could probably just melt a very fine rod of, or just place a very fine rod of plastic doweling in there, and use any threads you want. I would try to stick to 3mm. You might be able to bump up to 4mm if you're careful, but there's not a lot of spare meat on that little post there. Alright, so now I've taken my little tool bag off the top. Let's see if I can unscrew this hose. It is plastic threaded coupling here. Again, nothing super high quality about anything on the inside, and this is, I think typical of Ryobi, right? They're trying to bring you useful modern functionality at a price point. So they're engineering the best they can to bring you cool functionality and useful functionality, but at a price point. If this were, a real buy it for life product, I would expect to see some metal housings here, some aluminum or stainless, and certainly some metal threading. Hopefully, though, you aren't replacing this hose very often. If you are, there might be something else at play you need to check out. Oh, there's definitely nothing blocking this hose. I just managed to sprinkle a little glyphosate all over the place. So that's clearly not the problem. Unfortunately, I suspect it's something related to the pump. Bummer. Alright, have the battery in. But now getting nothing when I turn the switch. when I had it assembled, I would at least get a whine that sounded like a motor trying to work. And here's the problem why. Let's take a closer dive onto the switch mechanism. Alright, so this is one of those things that's either really clever or not really clever. I'm not sure which. This is not actually a rotary switch. This is just a plastic axle with a flat portion to it, right? Kind of like working with machinery. You'll have a ground axle to take a key. And then this is the actual switch on the left here, and it uses a little roller to switch itself on and off. So what this means is, you kind of have to have it assembled and have the pressure in the right places, holding this little switch steady so that it can do its clicky thing. And there we have the clicky thing. And there we have the whine. Alright, so now it's time to figure out what's going on with the motor and the pump. It's getting electricity, it's making a nice little whine, but I cannot tell that the motor is actually moving at all. So these, once again, are actual T10 bolts, screws, not T10 holes. They are not the security screws. They seem to be captive. I'll check that in a minute. They are going into proper bushings, which is very good. The bushings seem to be at least the thickness of the roller molded tank. And I said roller molded, but I see a seam, so maybe not roller molded, but some sort of formed, maybe vacuum pressed HDPE. I see a recycle logo on the bottom there where it helps nobody at all. I'll see if I can get that on film for everyone, just in case you want to know what this material is and whether you can recycle it. Alright, so motor housing is off. Interestingly, somehow there seem to be like little flecks of dust or something in the bushings there. What we have are some nice flexible rubber mounts. That's a very nice design touch that keeps vibration and noise down. Now, let's take a look at our motor. Okay, these are the bolts that hold the motor housing to the tank. It is a dead ringer for M407. It is a straight T10, not a T10 with hole. There is a metal washer that goes on the outside of the rubber mounts, and that's what makes you think, made me think originally like maybe it was a captive screw. It's not captive, just that washer is going to get stuck to the rubber over time. So you do want to be careful when you're disassembling these, not to drop and lose these like I've done a million times in my life. Let's go ahead and measure the length. Here's the length overall. Let me get you a better focus. There's the length overall. Seems to be a little over 20 millimeters overall. So remember to reduce size for the pan head. All right, I suspect the motor's not turning, so I'm going to disconnect the motor from the pump assembly. Now these are just Phillips. A little bit of a square to them in the middle, and to be honest, my normal Phillips bits that I use for carpentry work and general purpose were all a little too pointy, right? Alright, I finally got some good exposure balance there, looking good. Exposure balance, that's when you take two separate photography terms and turn them into one. Alright, so now we're going to see how you actually disassemble the pump from the motor. And because I know at some point I am going to have a tray full of screws and not remember which is which, let me go ahead and measure these guys right now. These are about 12 millimeters long. including the head, of course, right, because I'm not measuring them properly. And these are the ones that use the very blunt Phillips 2 head. They're about a 3mm, very coarse plastic thread, which is to suggest, again, unfortunately, that this is just screwing plastic into plastic. Very common with the cheap junk you get these days, but still not a preferred technique. Alright, when I take this cover off, I have a large rubber diaphragm here. This is definitely part of the pump assembly, as you can obviously tell, and a spring-loaded valve here of some sorts. So we got to be very careful to keep this guy on there. In fact, let me see if he even comes off. He comes right off, so there's nothing holding the spring in there. So I'm going to go ahead and put that spring in the parts tray before I lose it. This is all rigid plastic. We have some nice molding here, a nice groove for this grommet. Let me go ahead and turn it on and see what it does now. Now remember, I have the case apart, so my switch isn't held in place like it should be, so I have to kind of use two hands here to turn it on. Alright, so we have power, we have the very high-pitched whine, and nothing happening here. So back to off. This may or may not come out. I'm not going to mess with that. I do not see a seam there or there. I do see a seam here, which is interesting because, when you take the screw out that was holding the mounting bracket on, I expected this to be a seam and to be able to very easily decouple the motor from the pump. I'm honestly not sure why there is a seam there, because the rest of it seems to be one piece. And in fact, even this front piece seems to be molded in with this piece. So I'm not sure why they put that gap there. But it looks like I have to do the other side now as well. I also don't understand why there's wires running here. I guess we're about to figure that out. So I'll let you watch me remove these screws. I will figure out how to do the kind of time-lapse fast-forward thingy in the software. Right now, I am just trying to get round up on the massive amount of weeds we have, not just around the garden, but like out on the street and in the patio. And really, it's been too long since I paid attention to the garden, and I'm the only one that does it. So I really just want this thing to work. Again, very disappointed that they used security screws on the hose clamp. And what's odd is, using those Torx holes on the hose clamp, which is by far the most benign thing in here. But then everything else is just using regular Torx and this Phillips 2. I guess Phillips 2 is a bit of a rare bit. But I don't like that kind of approach they're taking. That style fastener doesn't add any fastening power. It doesn't add any torquing. The only reason to do that is to discourage people from removing the hose clamp. And if you're going to do that, why not use security bits for the main fasteners instead? All right, maybe I'll have to take a look. Maybe they did. Did they? Nope, they're just Torx. It's weird. I'm not going to call it a right to repair issue, but a little bit of a jerk move using those things unnecessarily. I mean, I understand that they have warranties on these things, and yeah, I could just take it to a warranty center and not worry about it. And a lot of my friends are like, well, why do you work so much? Why don't you just take that stuff in and let other people do it? Well, here's the thing, man. I'm traveling next week. I'm traveling a lot next month. And I want to get this done. Like I said, if I don't do it, nobody else is going to do it. And I don't have a lot of time to muck around with a repair center that's multiple towns away from me. You know, significant drive time there and back, and then Lord knows when they're actually open and what kind of gymnastics I have to do to get them to do the work. And then, quite frankly, I've read multiple stories about the repair centers not actually repairing these things. So I'd rather just handle it on my own. Alright. Once again, we get the little spring with the little gray cap, which in my case is stuck in this valve. So I have a tool for that. I tell anyone who'll listen, go to Harbor Freight and get these little $1 orange picks. They're really small, and you're going to look at them and go, well, what will I ever use that for? And then you buy them, and you end up using them all the time, constantly, for every sort of little thing you can think of. Alright, so we got that little valve in there. I want to say it's some sort of check valve because of the springs on these, but I don't know if that's really the case. But remember, we had one of those springs and gray things on both sides. These look to be rather symmetrical, you know, the hole going right through there. And again, this nice rubber sealant. Here's another check valve we need to be careful of. Okay, these valve seats come out. Alright, you gotta be careful here because there's some tension involved. I wouldn't want you to rip this or deform it. So we're gonna move really carefully here. And there's a good bit of tension on the top side there. So we're gonna leave it right here. And oops. Valve seat popping out. Good to see they're using replaceable valve seats. And now I can take the motor out. Okay. So what we learned here is that there's 6 screws that hold the motor in. Well, or maybe none. We have these screws that go through the motor holder guy. And remember how I just said this stuff is all unseamed? I don't understand why they have a seam there. Now I understand it. This fits entirely inside the casing. It's not a flush fit to the pump. It's actually going inside the pump, so there is no seam around here other than these 2 ears for the machine screws. And you know, at first I thought, well, maybe you have to take these 4 corner screws out too, but now that I see the backside, they do not go through the plastic. They sit entirely in the plastic. So once you undo these 2 motor brackets, you can pull this pump assembly off of the motor without undoing the millions of little teeny screws and messing with the check valves and the gaskets that I did right here. So now we have this thing pulled apart. Let's see what happens when I power this up. Absolutely nothing is happening. The motor is definitely defective. Alright, at this point I'm tempted to grab the meter out and make sure I'm getting 18 volts here. But let's just... I want to see how this does. This is a little bit... This isn't moving the way I'd expect it to move, in all honesty. Just being a little electric motor. Makes me wonder if somehow the motor failed catastrophically internally and is creating too much friction on the, whatchamacallit, the stasis or the blah blah blah. I don't remember my motor terms. Someone out there is like raging right now. Hey look, now it's moving. Just because I moved it by hand a little bit. Well, that's good. So it was just kind of some sort of friction issue inside. That's real good. Alright, I don't want to stop there because while I have this thing out, I want to give you guys as much information as I can. So whatever variable resistor thing that it uses to control its speeds seems to be working nicely. Okay. Well, this is good news. This bearing doesn't move the way I'd expect it to either, but to be honest, last time I played with a little micro bearing like this, it's either like totally industrial ones I use for little machines I've built, which kind of, they all suck to be honest, or they've been like those ASIC rated bearings for skates, for hockey skates, where you spin it and it just goes on forever like it's a perpetual motion machine. Plenty of grease though, no dirt, and again, I'm not even sure how dirt would get in here. It's so contained, and this entire machine is only used with liquids anyhow. Does it sit in dirty environments? Yeah, it sits in a shed. But the whole issue seems to have been related to friction. Now it's moving more like I would expect a motor to move. I can feel some magnetic resistance. I can feel little steps, even though it shouldn't be a stepper motor. Stepper motors are designed to move in like very specific increments, like a certain number of degrees at a time, so that you can do precision work. Like eventually it moves belts, and on the other end something moves like exactly 1 millimeter forward. That's what a stepper motor is. This should just be a regular motor, like a drill that just spins constantly. But I see the fans moving down below, and it's feeling good. Now, if I understood more about motors and wanted to take this apart, I'd be tempted to see what was happening inside that caused it to jam up in the first place, and think about maybe putting a drop of oil in there. By a drop of oil, I mean literally a drop of oil with a needler, right? I mean, people take oil, they get their WD-40 cans, and they spray like 2 ounces at a time on something, and like completely saturate something with ridiculous amounts of lubricant. Completely unnecessary, especially on something small like this. But it's working, so at this point I'm just going to reassemble it and go about my day, and hopefully I'm kidding, I can't stop here. How would I end up breaking it and being really upset at myself if I stopped here? Let's go ahead and remove these machine screws. These are proper machine screws. They're flat flush. I forget what you call that type. Let me go ahead and measure it real quick. I'm guessing a 4 millimeter. Yep, dead ringer. It's 4 millimeter by 0.7 threads, and it is 11 millimeters overall length, and threaded length I would say is about 9 millimeters. I'm going to leave that one right there. I'm getting a lot of different screws mixed up in my main part holder now, so I want to keep those a little bit separate. Again, I'm using a PH2 driver bit on these. This is a bit with a square portion in the middle. It's not one of those really fine-tipped Phillips that you sometimes see, and it has a blunt nose and it's gripping these quite nicely and doing a very, very clean job of removing these. Let's see. So I've opened that up. Now the question is, how do I remove the head of this guy? Or do I? Maybe the whole thing slides out? Nah, not really. This is keyed. Can you see that? Yep, there you go. So that's keyed, and there's the number 71 stamped into it. Don't know if that's a manufacturer code, a part code, a size code. I see no other markings on it. There is a marking on the bearing, which you'd expect because nobody makes their own bearings. The bearing says 508Z as in Z and SHNGTE. Shengti. So I say again, that's Sierra Hotel November Golf Tango Echo 508 Zulu 508Z. Was well greased. I might put a little more grease on there. For my next trick, it looks like I'm going to have to figure out how to get this thing off the key. I don't see set screws. I don't see snap rings. I think it's a press fit and no screws on the backside. You can see evidence of plastic, that kind of plastic riveting technique where they push the plastic rods through the other side and melt it down to hold it in place. Other than that, you know, solid external canister, which is good. I may not be able to take it any further than this. I can see bits of copper moving around in there, and again, I've totally forgotten my motor terminology. Maybe I'll have to Google that up a little bit, or maybe some of the electrical motor guys can light me up in the comments. But there we have it. Let me work on this a little bit and get back to you. Alright guys, after a little bit more research, I have decided this is where I stop disassembly. And the reason is, this eccentric is pressed onto that shaft. There is no set screw, there is no C-ring. So for me to get that off means some significant prying. I would normally use like a gear puller type device, but I can tell you right now, I don't have anything small enough to work on that. And the time it would take for me to rig something up and pull that up and further disassemble the motor just isn't worth it. Plus, you know, further complicating things is this housing is not screwed together. It's kind of melted together. If I got this metal sleeve off, you know, I don't see any cracks there. So this is definitely not meant to be disassembled and repaired. Now the good news is I learned something, and that's why I do this, right? Trust me, it'd be a lot easier to pay someone else to do this and yeah, spend a couple days messing around with their repair facilities, yada yada. I do this to learn. I do this to be self-resilient. And you know, really, I do this because I just gotta understand how things work. I'm just, if my brain isn't learning something, I'm you know, dying. Right? The day you stop learning is the day you die. So here's what I learned. This is called a vibration motor. This is pretty neat. They sell these online. It's actually very easy to find these vibration motor setups from industrial suppliers. You can also find 12 volt and 18 volt electric motors very easily. So if you had to replace this, if you could get the original Ryobi part, that's fantastic. Otherwise, you want to get yourself a vibration motor. Although, you know, because this inserts into the pump housing, you know, you're still going to have to get that eccentric off the end and be able to put this back on. Now, having this eccentric press fitted in also means I can't really replace that bearing there's nothing wrong with that bearing. It's moving perfectly fine. I'm just, again, if you went to a hockey store, or I guess a sporting goods store, and you got some bearings used for the hockey roller skates, when you spin them, they just go on forever. They're really beautiful things. This motor is also what they call a through shaft. So that's the other end of the shaft right there. And as I turn the eccentric, I can feel and see that moving. And I think that sits inside a really small bearing itself there. So what I'm going to do is just give this a single drop of oil on either bearing with my little oil needler, my needle oiler. This one is actually so old, it's actually made in Switzerland. I'm going to guess probably the 50s, but still going quite strong. Of course, if you go buy one now, it's not going to be made in Switzerland. You can pretty much guess where it's going to be made, and maybe it'll last you just as long if you're careful with it, maybe not. But I'm going to give this literally a single drop of oil, and the reason just one drop is I don't want it commuting around the inside. I don't want it commuting around the inside and getting sprayed around the inside, right? Because from what I read, what can happen is eventually lubricants can eat away at the insulation inside, and now you're out a motor. Now, to be honest, when you start reading about motor repair, it's very, very rare that you find stuff talking about these little DC motors, right? These guys are so cheap and plentiful, you just buy them and replace them. What you do is you find a lot of websites, engineering sites, discussing the maintenance of very large industrial electric motors that run large machinery. And those things you can completely disassemble and get down to the stator and the armatures and this and that. There's a good chance that this entire device, somewhere is going to break somewhere somehow long before the insulation inside the motors get worn. Who knows? But I'm going to go ahead and apply maybe 2 drops to the bearing. This is outside the motor here. We'll get that going. Now, something else I learned, this is really interesting. I have worked on motor pumps before, especially on the sailboat. If you have a sailboat and you have like an old diesel engine, you know what an impeller is. It's the little blades inside your water pump that keep the cooling water moving through your engine. You also know that if you run your engine dry and you ruin that impeller, you're not getting water, which means your engine's going to overheat and now you can't get back to dock. Well, this does not use an impeller. At first I was wondering if maybe the impeller was burnt in. I was going to find pieces of impellers inside. This is called a diaphragm pump. And you can buy entire diaphragm pump assemblies for like $20-30. So there's really no need to go maintaining the motor and the eccentric here, unless you just really want to. You can get an entire diaphragm pump assembly where your only challenge is going to be making it fit in the housing. And, with a Dremel and some padding, you can probably make a wide variety of them fit in the housing. It's going to have to be 18 volts because, there's no sort of voltage regulation going. This is an 18-volt motor. It's an 18-volt battery. And then you just need to adapt the inlet hose and the outlet hose, and that's not hard to do at all. A new pump is probably going to use very standard sizes. This probably is as well. So the way this diaphragm pump works is you have these diaphragms here, and to be honest, it works like lungs. The diaphragms expand and collapse, and as they expand, they're creating a vacuum and drawing liquid in, and as they collapse, they're pushing that vacuum, that liquid out, and they're doing that by way of those check valves. These little gray discs that we removed press against these valve seats and create kind of a one-way valve. And there's a one-way valve on the inside. There's one-way valves on the outside, and that allows them to draw water in through the one-way valve when they're expanding, and then push water out the other hose set when they're closing. So if we look at this a little bit more carefully, we can see that that's a valve right there. If we give that a little pokey, it pushes in. right? But there's a spring holding it closed. So when there's pressure on the backside of it, nothing will come out this way towards us. But when we're providing pressure this way, something will go in. It'll flow through and go that way. A check valve is how you create one-way direction with liquids and airs and things like that. So what the motor is not turning an impeller. It's literally just vibrating this housing in here, and you can see that there's grease in here. I'm going to add some more grease here because it looks like it's kind of commuted around a little bit. And it just vibrates this housing up and down. And that is apparently all it takes to get these diaphragms moving somehow and get liquid flowing. I don't completely understand it, to be honest, but let's go ahead and just reassemble this. Actually, before I reassemble, let me take a few other measurements for you, just for those folks who really do have to work on the motor. Let's go ahead and get a little bit lighter exposure for you, so forgive me. Let's measure this eccentric right here. Again, please forgive the real crap calipers here, but this eccentric is 10, 11, 12 millimeters, it looks like, in diameter. It is a half moon eccentric. I can't get to the shaft. Yeah. No, unfortunately, there's not enough space for me to measure the shaft. Let's measure the bearing. This bearing is 22 mil. This is going to be a standard bearing, I'm sure of it. I got you the numbers off the bearing, so it's easy to replace those. And remember that I did get you the actual model number. This is an RS775SH. Not sure what the H is for, but that if you Google the RS775, there's a ton of DC motors that carry this model number. And I think if you're going to replace just the motor, first of all, I do think that's going to be a challenge because I doubt, once they're assembled, I'm not really sure how you're going to press fit that eccentric onto the rotor. But I think the only big thing to look for is make sure that's 18 volts, and it can take the full juice that your battery puts out. So it looks like there's just enough exposed lead there that I might be able to meter it. Although, honestly, you can probably also just meter the battery itself and see how much amperage it puts out there. These things are not working all that super hard, but you just want to make sure that you put a motor in there that's going to stand up to the full electrical output from the battery and not burn itself out. Do these cycles, all that good stuff. Although, do these cycles in a backpack sprayer. I get the feeling if you're using a backpack sprayer every single day, you're probably not buying this brand. So let me go ahead and reassemble this guy. And now let's see how this works as a diaphragm pump, not just a motor with an eccentric on it. Oop. Oh, I got some output there. Oh, it's still messing with the switch over here. Remember, because I have the housing apart, the switches are just moving around. I got to kind of hold them in place to get them to work properly. All right, there's the volume, and look what happens when we finally hold this thing still, so it's not just wobbling all over the table. It's vibrating this diaphragm up and down using that eccentric that was in the motor. That's it. It's you know what this is, and that's enough expansion to get a very small amount. So remember, when this is screwed together, this is going to be holding still. That's enough expansion to get a very small amount of liquid in there and pressurize it and shoot it out the other end. So that's pretty darn cool. I definitely learned something very useful today. These little diaphragm motors are how you get small water pumps. So like the freshwater pump that I put in my boat definitely isn't using an impeller or a piston. It's using a diaphragm. Now, it may use a different mechanical function to move the diaphragm, right? So you can have diaphragm pumps where it's using an eccentric cam, and there's like a piston arm moving at eccentrics, and that's what pushes the diaphragm up and down. This is using what is simply called a vibration motor, and it's called a vibration motor because that's what it does. It has an eccentric there, and instead of everything moving very nicely coaxial to the motor, it's moving very off-axis, and some of them will even have another eccentric on the rear end to make it vibrate even more. So this is really cool. You can get these little motors really cheaply and make your own pumps. You can use them for doing things like, right off the top of my head, I'm thinking kind of a self-replenishing bird bath. Take this and wire it into some sort of smart controller and schedule that out with like IFTT or smart controller script, something where it comes on for an hour a day and pumps fresh water into a bird bath. Something my wife has always wanted. Certainly when it comes to Halloween, we definitely love our Halloween effects and ornaments and costumes. And I'm thinking that using one of these with a battery pack would make it very easy to make a very small pump for like fake blood, or even just a very iridescent fluid. We use a lot of black lights, and so like anything phosphorescent shines up for sure. And then these vibrator motors can be used for the obvious, but also for like making little rattle toys and like little decorations that bounce around on the ground. So you can make even little cute things for these. You can make a cute little puppet or a cute little doll or something, and put one of these vibrator motors in it, and it just kind of bounces around the ground. And then you could play with that even more and put springs on it and have it like really wobble around. Or if you're really good, you could figure out like a good spring tension and have that vibrating effect to make it actually kind of walk around, like scoot itself around. So vibrator motors are cool. That's something I haven't seen before, and never understood how a diaphragm water pump worked, to be honest. Never knew there was a diaphragm water pump. So I've learned a lot today. Now I'm just going to go ahead and put this guy back together, get it fitted up, and get some hoses attached, and make sure that it is pumping to the pressure I need. So that's how it works. It's actually pumping through this channel. So this is the inside of the lung that's pumping through. The inside there, where the motor went, is dry. See, these are sealed off. So this area is completely dry all the time. This is the wet area, right? This is the water. The water's coming in through there via this check valve and then going out through there. So that tells you this is the entrance hole, this is the exit hole. Now, of course, if you just disassembled it, you know that already. But to do this, we're going to make sure we have the spring properly seated there. If you don't get the spring on the little knob in there, that spring is guaranteed to fly around all over the place. You're going to lose the functionality of a check valve, and your pump will not work. All right, so as I was saying, if you want to retain the functionality of this pump, these check valves have to work, and for them to work, they need the springs, because that's what creates the one-way action. So you definitely want to make sure that spring stays properly seated on that post and seats around the valve itself properly. So I'm going to turn it sideways. You know what? The post seems a little bit smaller than the valve. Let's try this again. Nope, the post is a little bit bigger than the valve, and the spring will stay on the post. And actually, let's be even smarter. let's see if the valve itself will stay on the spring also. It does. Good enough. So, boom, we get that guy seated. And a whole bunch of screws. I don't think it's sitting properly on the gasket. I don't think the diaphragm, which is also the gasket, I do not believe it is sitting properly in the groove, and that if I just keep torquing this down, something's going to go wrong. And I just want everything to go alright, alright, alright. Things go wrong. They do all the time. But, you know, if you can... Over the years, you learn how to be a little bit more careful and try to keep things going right more than they go wrong. Remember, this is going into nothing but plastic, so you can't sit there and torque these things down and make it do what you want to do. You gotta have it lined up the way it wants to be. If you make it unhappy, especially if you try to, like, you know, monkey one of these screws down in there when it doesn't want to be, it's gonna let you know who the boss is very quickly. So again, careful to get my spring onto the little post on the valve, not just pressing against it, but actually seated on it. And yeah, that's it. That's it there. Let's see how this guy does. Yeah, that's a much better fit. Also notice how I'm not just screwing a screw down and then going to the other side, right? I'm kind of moving around in a little star pattern to distribute the downward pressure a little bit more evenly as I go. That's going to help me avoid stripping out the plastic by not putting too much tension on anything at one point, and it's going to help me get that pressure distributed evenly and make a good waterproof seal here again. So I'll start with that guy, get a little bit of torque on it, a little bit of pressure on it. Alright, so I got the pump housing screwed back together. Nice clean lines, meaning I have it all clamped down very evenly, very thoroughly. I basically took each one to torque, right? I mean, you can feel when it's bottomed out and it's not going to go any further, and you want to stop torquing it. Now I'm gonna grease the inside here a little bit. You can tell that there's some grease. Presumably to keep the Eccentric on the motor from just wearing down this very thin plastic sleeve that it rides on. I'm going to use brake grease. Why brake grease? What they had on here was some black thick stuff. I don't think they're using Molly B denim, but I'm going to use brake grease because it's a pretty safe choice. It's high temperature. This thing is not going to create so much friction that it's going to create a temperature problem. But it's high temperature. It's thick, so it doesn't get thrown around a lot. It pretty much stays where you put it. And most importantly, it's a pretty safe grease for rubber fittings and things like that. Now, none of the rubber is actually exposed through here. This is all a dry surface in here. But just in case, it is a pump. This should do okay. But to be honest, the real reason I'm using brake grease is because I had this tube and brush sitting right there on my orange automotive cart, and so I'm using it, and that's that. And you won't question me. You can use what you want. Bearing's flowing pretty nicely. The rotor is definitely spinning quite nicely now. So again, I have no idea what would have caused that rotor to bind. It couldn't have been the bearing. Let's say the bearing was completely frozen. The bearing is outside of the motor housing. That wouldn't have affected it at all. Now, maybe the end of the rotor here, maybe somehow that was binding, but no idea. Either way, all I had to do was open it up and kind of crack it, so to speak. All right, after a short little rewind action, also gave the camera a chance to cool down a little bit. I saw that the wires go behind, and the motor faces down, so we're going to want... Come on, where's the clamp for these guys? So we're going to want this guy clamped in just like this. No, that can't be right. Let's flip that around the other way. See how they're higher up on one side? Yeah. That's better. So that's... Alright, so after a little rewinding, we see that the motor goes on the bottom with these wires between the motor and up here below. And, I never took this apart to figure out what this is. I expect that is going to be like a flow meter that activates when actual flow is generated, like when you squeeze the handle. But we're going to mount this up right back there. Again, we're using actual T10 machine screws with washers. Wait, stop. What am I thinking? We know that it vibrates. I saw the diaphragms moving, but does that mean it's going to flow water and liquid the way I need it to? So I was about to put that thing together with a semi-permanent thread sealant, and then reassemble the whole thing, only to figure out whether it works or not. Stupid moment. We're gonna put this thing back together and see if it sprays liquid or not. All right, so here's how we're gonna bench test this thing. You can bench press it too. I don't know. It looks a little bit heavy. Okay, so here's how we're gonna bench test this thing. First, after finding your half leftover cup of coffee from 5 o'clock in the morning and microwaving that, you're going to go dig out the old box of plastic hoses you have. You know that time the wife was cleaning out the refrigerator and just determined she didn't need that little produce bin thing, and meanwhile you just finished doing a bunch of gear oil, you had a bunch of messy stuff, you put it in there, you put it all the way at the top of the shelf in the back of the garage, you forgot about it for years until just now when you realize you have a collection of clear vinyl hoses that are perfect for little jobs like this. So you get the hose out, you realize, of course, it's been sitting in not just that kitty litter stuff that picks up granules, but also plenty of chemicals of unknown origin. So you wipe down the outside with a paper towel, you blow the inside out with your air nozzle on the compressor. You wait about 5 minutes for your compressor to finish catching up. You find a bucket, you fill it with clean water. Now the reason you blow that thing out, and ideally you would pump some water through it first, is because you don't want any of that sawdust particle stuff going inside the pump. But it is actually pretty clean because apparently I didn't bother cleaning it out too much when I was done with it. So there might be some sort of lubricant going through that pump. That's not going to hurt it one bit in my opinion, because we're going to put plenty of water through it. And then if it does work, we're going to put 4 gallons of Roundup through it. So that's going to flush out any lubricants that get in there. And then what we're going to do is really just kind of hold the nozzle away from our face. That would be a good idea. Probably away from your feet too. And we're going to turn the sucker on and just see that fires up. Alright, so making sure that the nozzle is not on. In fact, yeah, let's just make sure that's not on. We'll point it over this way, because there might still be some glyphosate in there somewhere. We probably don't want that going in our faces. And again, because we have the housing off and our switches are kind of wonky here, we're going to play with what we need to play with here to get the switches going. There we go. We have movement. We can see the fan moving. It's not that high-pitched whine anymore. It sounds a lot better. So this guy is actively working. Is it drawing in fluid though? Alright, so now with our clean vinyl hose inside a large bucket of water, we want to make sure the water goes up above the hose end. This one wants to keep curling up because I stored it curled, and it hasn't had enough time to really loosen out and straighten up. You want to make sure the water is covering the hose, and look, you don't want to put a brick or stone or anything in there to hold the hose down, which is what I almost did, because that's going to introduce granules and particles and dirt into that water, which is going to go through your pump. Remember that when it's in the tank, there is that very fine mesh screener inside the tank preventing that from happening. That's not inside your bucket here, and you don't want that stuff getting in and messing up the pump you just so carefully resurrected. So we're going to make sure that our switch here is off and it's firmly disengaged, so we're not going to have the leftover glyphosate that's in here spraying all over the place. And we have to do the little happy dance with our switch here to get it to work, because it is moving, because the other side of the housing is off, so the switch is moving in ways that normally doesn't. And now, for the moment, let's see. Come on, do something. I see water coming up the tube. That's good. It's purging the air. Alright, so this is good. You can see the liquid coming up the tube as the pump works the air out. And there you have it. Beautiful, wonderful water pressure, and plenty of it. So we've bench tested it. It's working like a champion. Now that we got the little motor working, now it's just time to reassemble the whole thing. Alright, there are a couple of different part numbers and markings and sort that I want to take you through here. This is the hose that connects. This is the blah blah. Alright guys, all we have to do now is put it back together and I'm good to go. Before I do that, I want to get you a few additional markings. This one is the pickup hose from the tank to the pump itself. It is an EPDM hose, which is good. That's the kind of hose material that they use in cars. It stands up to chemicals really well. And it says 541717 EPDM IT, India Tango, 11. Hey, it's me. So obviously when I was recording, I read that wrong. It's not IT, it's JT, 11. Now, let's take a look at some of the electronics wiring here as well. We have this assembly up here, which I never really got into. I suppose this might be like a flow detector, so that's only pumping when there's actual demand. Small wire. It's DC. Doesn't have to be big. Nice footing, actually. The connections. This one is a tab connection, but very nicely sealed with some very professional shrink coating there. We have a good crimp connector here. I like this. These crimp connections, obviously it's very fast on the factory floor, but it's a good mechanical connection. Stands up to vibration and movement a lot better than just a solder connection. Did you know that on boats you actually are now allowed to use soldered wire connections because the vibrations end up breaking them up? And then of course they all go to the switch control, which we'll go in depth here in a second, and to the battery. Very simple battery interface. We just have two tabs that are coming off the post of the battery there, positive, negative. Now let's take a look at the switch itself. First we have the rotary switch. This is acting as the power regulator as well. So this is going into what I presume is a resistor. I'm going to try to get that for you. Let me grab a still. All right, and then we have what I presume is a potentiometer here, or a pot. I'm having trouble getting everything focusing here. You know, it's really difficult when you constantly move in and out to these small shots, and it gets kind of macro on you. But this is reading Bravo 103. Taking it close with the resistor here, MXON, looks like an L, LAMXON. Not going to be able to get that full part number for you. I'm sorry. It is potted, which is nice. Helps with the waterproofing a little bit. And now on to this roller switch over here. Oh, we have assembly numbers on the big rotary switch housing itself. These read 21051168. The bottom number reads 280721003. And again, let me try to get a decent shot of that for you. There you go. This is stamped on the back of the plastic housing. If you had to, you could 3D print this housing, no problem at all. This metal tab here doesn't seem to have a use that I can tell. So I'm guessing what this is a potentiometer and a resistor, controlling the voltage that actually goes out to the pump. That's a guess, though. I don't know that that's a resistor. It could be something else. I am no electronics genius, as you can tell. All right, so now this switch is the actual on-off switch. This guy has, tab here for the power coming in. Very nicely booted, very professionally done. There's a spare tab, I guess maybe for a common that isn't going out. A couple of markings here. Let's see if I can get those on video, or at least in a still shot for you. So we have 3 pinouts. And C and D, and the one on the side that says common or ground. Oh, sorry. And this is JLABEN. Giaben, J-I-A-B-E-N. And alright guys, with the pump back on and the switches back in place, I'm ready to just screw the housing back together. Remember, I'm going to do that with 7 of these plastic screws, and then I actually have to put that hose clamp back on first. So that hose clamp is going to use these tiny, oh no, these very tiny, very easy to drop Tex security screws. They're T10 with a hole. They have a little pin in there. You're going to have a T10 with a hole in it to be able to get proper traction on these and put this back in. And then it's just 7 of these plastic screws and 2 of these machine screws in the battery compartment. Before we do that, let's take one look back here and talk about a couple of things we saw. First of all, disassembly and reassembly is surprisingly easy. The designers really thought this out for easy floor operations. You can tell here even that they are, connecting harnesses separately on each terminal end and then just clamping them in the middle. This crimp connection is very fast, good quality connection. Everything is booted. It's a good design. Now, even the bracket feet, even the mounting feet, the rubber feet, slide right out of that bracket, and very easy to put together, very easy to repair, and actually probably decreases their manufacturing costs a good bit, right? Having that rigid plastic as one component, then the rubber feet, and just sliding them in very quickly and easily to make that full assembly. Let's talk about what I don't see here, which is, namely, I don't see any waterproofing at all. So your battery here is coming straight into 2 tabs. Now these are soldered, soldered connections versus mechanical and something that moves around a lot. who knows? There's a good chance that these may go out sometime. So if you ever pick it up and there's just like zero power, nothing's working, open it up, and I would definitely start with those soldered connections first. And besides, they're the first thing from the battery, so obviously you would start there. The switch design and then having the pot and the resistor in here is a clever design. I like that. I like using the little roller on the half flat axle to switch it on and off, because that's what gives you, as the user, gives you that good hand feel. You get that audible click, you get that haptic feedback, and you can really tell when you've dialed it into the off position or not. That's good design. I like that. The hose here just threads on instead of being crimped or anything overly permanent. Now, again, everything so far has been kind of commodity parts that should be really pretty easy to source. Sourcing a diaphragm pump, sourcing the 18-volt motor, very easy. Sourcing the whole assembly is very easy. There's a good amount of room in the housing. Your biggest challenge, I think, will be dealing with form factor. Whenever something is going into a very specifically fitted case, dealing with form factor can be an issue. But getting a replacement 18-volt diaphragm pump is no problem at all. These hoses, I did not measure the thread. Actually, I need to do that before we quit. This is a barb hose connection. That's no problem at all. This, I suspect, is going to be a very standard metric fit, and I do like the fact that it screws off. I don't like the fact that it's just a plastic coupling, but that's better than having like one side plastic and the other side metal, because that would just tear things up as you assemble and disassemble. At least when it's plastic against plastic, you get a little bit of kind of molding effect. And we see that the crimp connection to the hose itself is metal. This is a good quality hose. All in all, really, I don't see any cheaping out of components. The only thing I find questionable are some aspects of the motor. I mean, we'll see how long that lasts, but who cares? Because you can get a new one for $15-20 online. So this is not some random, obscure, super proprietary part that you'll never, ever be able to replace in your life. And, to be honest, for the price of these backpack sprayers, I think this is pretty solid. It's not sealed, right? Water can intrude in any variety of manners. First of all, there's no gasket between the housing at all. So, the entire housing, every seam where the tank goes up against it, that's wide open to leaking in water. Not a huge fan of that, because, these absolutely will end up leaking. You will get water down your back at some point. I wonder if they could have fitted a gasket in here, something, done anything to make that a little bit more watertight. Maybe an O-ring or a split O-ring, a split grommet here at the housing where the little power knob goes through. So just be aware that there's nothing waterproof about this at all, even though its job is to hold and disperse a lot of water. So that means you can't leave this outdoors. If you do, you're going to get, over time, you're going to get water intrusion, and you're going to see things go bad. Other than that, though, to be honest, nothing about this made me scream, terrible job. Nothing about this is cheap or crappy. Some of it is inexpensive and absolutely is built to a price point. But, I think we've all taken stuff apart to find that the insides are just, an absolute mess, and that's not the case here. Even even your milk jug here, even the tank, is recyclable, and it has some completely indecipherable white on white, raised, embossed, whatever you call that, embossed, raised, lettering and numbering. It's HDPE. It says like 02. Maybe I can get a still picture for you, but I doubt it's even gonna come up at all on the camera. That might help a little bit. It's just impossible to try to read the white on white embossing. To be honest, I can't really even tell. It's a bunch of codes. It's HDPE. It's O2. I guess it's like recycles class 2. And then like a part number, a 3166 something 80s, blah blah blah. All right, here's the real truth. Are you gonna find an injection molded or blow molded, roller molded HDPE tank that fits the form factor of this housing? No, you're not. This is going to be the one thing that you cannot replace yourself. You're going to have to get that from Ryobi or just make your own housing, and at that point basically you're building your own backpack sprayer, which you know, now we realize isn't all that hard, to be honest. But I don't know why I did that. Probably because I spent the better part of my Saturday making this video for you and did not want to leave seeing markings I hadn't captured on film yet. Anyhow, I'm pretty impressed with this little guy, other than that motor seizing for no apparent reason. That bothers me, that concerns me, but at least now I have that motor documented. I can see if Ryobi sells it separately. I can definitely buy the motor separately. I've already Googled that and it comes up plenty. Don't know if I can easily get that anvil off. I mean, I know I have the tools, and if I want to just monkey wrench so I can get that anvil off. Getting it onto a new shaft without damaging that shaft might be a different story. So I'm a little concerned about that motor, to be honest. But, you know, I think maybe the secret is I just need to fire it up every once in a while. I probably have not touched that. Probably have not touched this since this time last year. So 12 months of sitting in a shed. We'll see. Anyhow, I'm going to get it back together and get to killing some weeds. Hey, you know, just going back to the screw-on hose here that leads out to the actual handheld assembly. It's having a little trouble sizing it, to be honest. It's definitely an M20, but it's just not threading onto the 1.5 here. We can take a look at the 2.5, and we can just see right off that that's nowhere near a match. These are giant threads. But it's an M20 for sure. It's just not quite 1.5. And, you know, unfortunately, this particular set I have does not have 1.25 or 1.0 on it. But I suspect this might be a 1.25. Here's another little clever design feature. This the hose clamp it not only serves to kind of hold the motor and the holes together, but actually serves to prevent the threaded fitting from backing out. It has a little spring-like indentation there. You want it facing this way, right? Because if it backs out, it's going to go counterclockwise. And you get that little spring indentation against one of these ridges in the twisty turny guy, and that'll prevent it from backing out. So that's how you want to orient that thing. Clever. You want to do these outside corners first. The reason being, the tanks have a small plastic loop, and these screws go through that loop to hold the tank into the housing. So you just want to get those in first so that the tank stays in position, then it's a lot easier to do the rest. Zoink, zoink. Remember, don't over torque, man. This is just plastic. Like, it's not suspension parts. It's not going to fall apart if you don't torque this to 88.5 foot-pounds. The worst thing that happens if you don't torque these enough is the housing develops a small gap in it, and you notice it later on and tighten up the screws. If you over torque them and you strip that plastic, you're going to be cursing, I guarantee it. That's why I hate plastic screws. They're really kind of little bit of a one shot. Definitely quicker and easier in the manufacturing. You zip it in. You got a preset torque limiter. But in terms of, taking them apart and maintaining or repairing, these plastic screws can go out pretty easily. Oops.